This is Faizan Kagti and welcome to our lecture series of Basic Mechanical Engineering. In our last session, we have discussed about thermodynamic system, then classification of thermodynamic system and properties of thermodynamic system. Now in today's session, we are going to discuss about some basic terms or basic definition, along with that certain thermodynamic terms, okay, which will be used in our subsequent chapters. So let's begin with our first definition. There is a basic term force. So what is force? So we are very much familiar with the term force, and we usually say that force is equal to mass into acceleration. But in actual case, if we want to define force, then we would say that it is an agent which produces or tends to produce or which destroys or tends to destroy motion of a body or motion of any substance. So how we have found out the equation of force? So we would say it is based on Newton's second law of motion, and from that we get an equation that force F is equal to mass into acceleration. Now the next term which we need to keep in mind is that we are going to work in SI system, that is international standard. So for that the unit of force we need to take as Newton. So there are several units of force, as you can see on your screen. That is, first is a Newton, then it is dyne, then kg force and pound. Now you need to keep in mind the conversion. That is, 1 dyne is equal to 10 raised to minus 5 Newton, or we would say 1 Newton is equal to 10 raised to 5 dyne. The next conversion which we need to keep in mind is kg force into Newton. That is, 1 kg force is equal to 9.81 Newton. Okay. Now the next two terms which are related to force is 1 Newton force and second one is a 1 kg force. So the first question comes that what is 1 Newton force? So we would say that a force which produces an acceleration, you need to keep in mind the force which produces an acceleration of 1 meter per second square in a body of mass. The mass is specified, the mass is 1 kg. Then such a force is called 1 Newton force. Similarly, we would say that the force which produces an acceleration of 9.81 meter per second square. Yes, the gravitational acceleration, that is a gravitational force, the force due to gravity. So that force which is exerted on 1 kg mass is called 1 kg force. Okay, so these two terms are most important from our exam point of view. Okay, so next term we are going to see, that is pressure. So let's see it. Now we know the basic definition of pressure. It is force exerted on a body per unit area. The unit of pressure we take as Pascal, then another unit is bar, and a new unit which you are going to see is a pound per square inch. Now the conversion also you need to keep in mind, that is 1 bar is equal to 10 raised to 5 Pascal, and similarly 1 Pascal is equal to 1 Newton per meter square. So the formula of pressure is P is equal to force upon area. From that we can say Newton per meter square. Similarly, 1 bar is equal to 14.7 psi, pound per square inch. So you would have heard this term psi. PSI term is usually provided while filling a compressed air. So whenever you go for filling the air, you would have noticed that we are using 30 psi, then 35 psi, then 40 psi. So what is that psi? So we would say pound per square inch. That is the pressure of a compressed air. Okay. Now the question comes that what we are going to study new in this. So we would say that we are going to see what is standard atmospheric pressure, then what is gauge pressure, then absolute pressure and absolute zero pressure. So on your screen you can see I have shown a figure which indicates the relationship between absolute pressure, gauge pressure and atmospheric pressure. Okay, so let's start with the atmospheric pressure. Now there is a difference between an atmospheric pressure and a standard atmospheric pressure. Atmospheric pressure is usually the pressure which is exerted by air. Okay, whereas a standard atmospheric pressure is a pressure which is exerted by air at a mean sea level. We would say that the atmospheric pressure is not remaining constant. That is, as we change our position, that is in terms of altitude, we would say air becomes thinner, which means that atmospheric pressure that will be exerted at a particular height will be lesser, right? So at an elevation, the pressure reduction is up to 0.98 bar, okay, which means the pressure range is usually from 0.98 bar to 1 bar. Okay, so now let's see the definition of a first term, that is standard atmospheric pressure. So we would say, as I have told, that it is a pressure exerted by atmospheric air at mean sea level, and it is also considered equivalent to a pressure exerted by mercury column of 760 mm. Okay, so the device which is used to measure atmospheric pressure is barometer. Okay, now let's take an example that we know the formula of pressure P is equal to rho g h. Now according to that formula, we are placing a value of density of mercury as 13,600 kg per meter cube. G is a gravitational acceleration, that is 9.81, and h, you can see that it is equivalent to 760 mm. So mm is a millimeter, converting it into a meter as we are working in SI system, right? So 760 into 10 raised to minus 3. So we get a answer of pressure P is equal to 1.01325 into 10 raised to 5 Newton per meter square. Further converting it into bar, we can write it as 1.01325 bar. So by using this equation, we can say that atmospheric pressure is equal to 1 bar. Okay, now on your screen, as you can see, I have shown 2 points in a diagram, that is at point A and another point is point B. Point A, if you notice, is above atmospheric pressure line, whereas point B, as I have shown, is below atmospheric pressure line. Okay, so let's consider the situation at point A, that at point A, I have taken my tire, automobile tire. Okay, now initially when we are not filling any air in a tire, so we would say that atmospheric air is present inside a tire as well as outside a tire. Okay, so both the side the pressure is going to be exerted, and so the shape of a tire retains. Okay, but when a same tire is placed on a surface, that is on a road, and some weight is exerted on it, so what is going to happen? So we would say it is going to compress. Right. So for resisting that force of a vehicle or a pressure exerted by a vehicle on a tire, we need to fill a air. That air is a compressed air. So whenever we fill a compressed air in a tire, we are actually increasing the pressure inside our tire to resist the force of a vehicle. So that pressurized air which is filled in a tire has a pressure which is called a gauge pressure. Okay, so you need to keep in mind that a gauge pressure will always be greater than a atmospheric pressure. For that, as you can see in a diagram I have shown, at point A, that is from atmospheric pressure line up to point A, is a gauge pressure. Okay, now the next question that can come is, what is the total pressure inside a tire? So atmospheric air is already present, plus we have added some extra air. That air has a pressure that is called a gauge pressure. So the total pressure is atmospheric pressure plus gauge pressure, which is called the absolute pressure. So as you can see, I have shown that absolute pressure is always measured from absolute zero pressure, that is called a perfect vacuum. So it is represented by a straight line starting from absolute zero pressure line up to a point A, which represents a absolute pressure. Now similarly, you can see that I have shown a point B below atmospheric pressure line, which indicates that the pressure is below the atmospheric pressure, which means it is going near to the absolute zero pressure, which is a perfect vacuum. So let's say that at point B, the pressure existing is called a vacuum pressure. Now my question comes that how much is the absolute pressure at that point? So we would say that absolute pressure in this case, again the pressure is measured with respect to a zero pressure, right? So the absolute pressure will be equal to the total atmospheric pressure minus that vacuum pressure. Okay, so that will give me an absolute pressure at point B. So over here you can see on your screen I have written a definition of a gauge pressure, that is the pressure above atmospheric pressure is called a gauge pressure, and it is measured by taking atmospheric pressure as a reference line. Similarly, vacuum pressure, so it is a pressure below atmospheric pressure, and it is again measured by taking atmospheric pressure as a reference line. Whereas absolute pressure is a total pressure which is measured by taking absolute zero pressure as a reference line. Now the device we need to keep in mind that the device which is used to measure gauge pressure is called a pressure gauge and manometer. Okay, both these device construction and working we will study in our chapter of properties of steam and boiler. And you need to keep in mind atmospheric pressure is measured by a device called barometer. Okay, now let's see our next topic, that is the next term is work. So let's begin. Okay, now what is work? So we know the general definition of work. So work is said to be done if a body on which force is applied moves through a certain distance. That is the basic definition. Work is equal to force into displacement. Right. So on your screen, as you can see that I have shown a figure. In that figure, two objects are shown. That is, one object has a weight of 300 kg, another object has a weight of 100 kg, and a person is pushing. So in a first case, when a person is pushing a weight of 300 kg, that is a displacement, or we would say object is not moving. In that case, we would say force is applied, but work is not done. Whereas in the second case, when a person is pushing a weight of 100 kg, then we would say that that object is covering a distance of 6 meters, which means a displacement is present in the second case. So force into displacement, which means work is done in this case. So general formula of work is, as we know, that F into D. Now further resolving that formula, we can write force is equal to pressure into area. Right, so pressure into area into displacement, which means the final position of an object minus an initial position. So the formula can be written as P into dV, where dV is a change in volume. So area into distance traveled, we would say, is a volume covered. So P into dV is another formula for work done. Now P dV is a formula which will be applied to our closed system. So in a diagram you can see that in a first diagram I have shown a piston cylinder arrangement in which a heating operation is done. Heat is supplied to a gas which is present inside a piston cylinder arrangement. So we are actually seeing our sign convention for work. So the first case represents a work done by the system. So whenever a gas or a system pushes a piston in an upward direction, then we would say work is done by the system. In that case, whenever we obtain work from a system or a work is done by a system for us, then with respect to us, the sign convention will be considered positive. Whereas in a second case, as you can see, work done on the system, in that case, initial state, the piston is at a higher volume, okay, having a high volume, whereas in a second case, a force is applied on a piston for compressing a gas, right? So in a second state, piston has moved from in a downward direction, indicating that work is done on the system for increasing the pressure of a gas or for compressing a gas. So I have used my energy to push a piston in a downward direction, which means work is done on the system and my energy is utilized. So for that we are going to consider the sign convention negative. Okay, so you need to keep in mind work done by the system is positive, whereas work done on the system will be considered as negative. Okay, now let's see our next term. This will be used in our while solving a numerical, so you need to keep the sign conventions in mind. Okay, so let's see our next term, that is energy. So let's begin. Now we know the basic definition of energy, that is a capacity of doing work is called energy. Now we would say it has an ability to change its form. Okay, now what is the unit of energy? So we would say joule. We have discussed about various types of energy, that is a nuclear energy in our topic prime mover, right? Then kinetic energy, then potential energy, then chemical energy of a fuel, etc. Okay, so on your screen you can see I have shown one of the figure in which a wind farm is shown, indicating that a kinetic energy of a air is imparted and it is converted into a rotational motion, that is a mechanical power. That is a change in energy from kinetic to mechanical energy. Now what we need to focus in this topic is what is high grade energy, and second, what is low grade energy. Now high grade energy is the one whose conversion into mechanical power is completely done, neglecting a transmission losses. Okay, mechanical power means the rotational motion, that is a shaft power. So whichever energy whose conversion is almost 90% possible into mechanical power, then such energy is called high grade energy. Okay, so which type of energy are involved in this? So we would say the one in which there is no heat interaction. You have to keep this in mind. That is, heat is a low grade energy. So which type of examples are present? So we would say the examples are hydel energy, that is a hydroelectric power plant in which there is no heat interaction between a system and a surrounding. Then after, tidal power plant, or we would say tidal energy, again potential and kinetic energy of water is utilized, right? Similarly, windmills, that is having a mechanical power, or kinetic energy of wind is converted into mechanical power, as you can see on your screen. Okay, now what is low grade energy? So the energy whose only certain portion can be converted into mechanical power is called a low grade energy. So in this type of energy, there will always be a heat interaction between a system and a surrounding. So for example, what comes under a low grade energy? So we would say internal combustion engine, in which combustion takes place, heat energy is generated and conversion takes place into mechanical power. But only we would say 60% conversion is possible, whereas in case of a high grade energy, almost 90% conversion into a mechanical power is possible. The next example is coal power plant, that is we are using a steam turbine in that case. And similarly, nuclear energy, that is a nuclear fission reaction, exothermic reaction, again a heat energy is generated, right? Then after, we would say solar power plant in which solar energy is utilized. So all this comes under category of a low grade energy. Okay, now let's see our next topic, that is what is power. Okay, so we know the basic definition of power. Power is work done per unit time. Its unit is joule per second, or even it's called a watt. Now what new we are going to see in this term? So we would say we are going to study two types of power. The first type is the indicated power, and the second type is called a brake power. Now what is indicated power? So both these terms are related to internal combustion engine. I am just giving an overview that IC engine has certain strokes. Okay, so let's take an example of a 4-stroke engine. It has a suction stroke, then compression stroke, then comes a power stroke, during which combustion takes place. That is a combustion of petrol or diesel takes place. Then after comes the exhaust stroke, in which whatever hot gas is generated inside a cylinder are leaving the cylinder. Okay, so whenever a power stroke or a combustion takes place inside a cylinder, so we would say a power is generated. That is, a pressure is exerted by a gas on a piston. As you can see on your screen, a piston is moving in a downward direction because of a combustion. So that power is called a indicated power. So because of this indicated power, the piston is going to move in a downward direction, that is going to perform a linear motion, and that linear motion, that push is given to a shaft which is called a crankshaft, and that shaft is performing a rotary motion, that is called a mechanical power is generated, and that power is even called as a brake power. So we can say that a brake power is defined as a power which is available at IC engine crankshaft. So with respect to IC engine, there is a term called an efficiency, that is a mechanical efficiency. So we know the general formula of efficiency, which is equal to output upon input. So we can write eta n is equal to output. What is an output? So we would say a brake power, that is a mechanical power, upon input. So what is the input? So we would say indicated power is our input, because of which brake power is generated. So the detail about this topic we will see in our actual chapter of internal combustion engine. Okay, so today we are keeping up till here, and we will continue in our next session with our terms, that is thermodynamic terms. Thank you all.